just continue on the thread of Chomsky because it's really interesting. Because as you're discussing disagreement, to the degree there's disagreement, you're also telling the history of the study of language, which is really awesome. So you mentioned context-free versus regular. Does that distinction come into play for dependency grammars?
No,
Okay.
Not at all. I mean, regular languages are too simple for human languages. It's a part of the hierarchy, but human languages are in the phrase structure world are they're at least context free, maybe a little bit harder than that. But so there's something called context sensitive as well, where you can have, like, this is just the formal language description. In a context-free grammar, you have one. This is like a bunch of like formal language theory we're doing here. But
I love it.
Okay, so you have a left-hand side category, and you're expanding to anything on the right. That's a context-free. So like the idea is that category on the left expands independent of context to those things, whatever they are on the right. It doesn't matter what. And a context-sensitive says, okay, I actually have more than one thing on the left. I can tell you only in this context, I have like a left and a right context, or just a left context or a right context. I have two or more stuff on the left, tells you how to expand those things in that way. Okay, so it's context sensitive. A regular language is just more constrained, and so it doesn't allow anything on the right. It allows basically it's one very complicated rule is kind of what a regular language is. And so it doesn't have any, I was going to say long distance dependencies. It doesn't allow recursion, for instance. There's no recursion. Recursion is where which is human languages have recursion. They have embedding, and you can't, it doesn't allow center embedded recursion, which human languages have, which is what
center embedded recursion. So within a sentence,
Yeah, within a sentence. So here we're going to get to that. But I the formal language stuff is a little aside. Chomsky wasn't proposing it for human languages even. He was just pointing out that human languages are context free. And then he was most for human, because that was kind of stuff we did for formal languages. And what he was most interested in was human language. And that's like the movement is where where he sort of set off on the, I would say, a very interesting but wrong foot. It was kind of interesting. I agree. It's kind of a very interesting history. So there's this. So he proposed this multiple theories in 57 and then 65. They all have this framework though. It was phrase structure plus movement. Different versions of the phrase structure and the movement in the 57. These are the most famous original bits of Chomsky's work. And then in 71 is when he figured out that those lead to learning problems. That there's cases where a kid could never figure out which set of rules was intended. And then he said, well, that means it's innate. It's kind of interesting. He just really thought the movement was just so obviously true that he didn't even entertain giving it up. It's just obvious. That's obviously right. And it was later where people figured out that there's all these like subtle ways in which things which look like generalizations aren't generalizations, and they across the category they're word specific, and they kind of work, but they don't work across various other words in the category, and so it's easier to just think of these things as lexical copies. And I think he was very obsessed. I don't know. I'm just guessing that he really wanted this story to be simple in some sense, and language is a little more complicated in some sense. He didn't like words. He never talks about words. He likes to talk about combinations of words. And words are, if you look up a dictionary, there's 50 senses for a common word, right? The word take will have 30 or 40 senses in it. So there'll be many different senses for common words. And he just doesn't think about that. Or doesn't think that's language. I think he doesn't think that's language. He thinks that words are distinct from combinations of words. I think they're the same. If you look at my brain in the scanner while I'm listening to a language I understand, and you compare, I can localize my language network in a few minutes, in like 15 minutes. And what you do is I listen to a language I know, I listen to, maybe some language I don't know, or I listen to muffled speech, or I read sentences, and I read non-words. Like I do anything like this, anything that's sort of really like English and anything that's not very like English. So I've got something like it and not, and I got to control. And the voxels, which is just, the 3D pixels in my brain that are responding most is a language area. And that's this left lateralized area in my head. And wherever I look in that network, if you look for the combinations versus the words, it's everywhere. It's the same.
That's fascinating.
And so it's like hard to find. There are no areas that we know. I mean, that's it's a little overstated right now. At this point, the technology isn't great. It's not bad, but we have the best way to figure out what's going on in my brain when I'm listening or reading language is to use fMRI, functional magnetic resonance imaging, and that's a very good localization method. So I can figure out where exactly these signals are coming from, pretty, down to, millimeters, cubic millimeters or smaller. Okay. Very small. We can figure those out very well. The problem is the when, okay. It's measuring, oxygen. Okay. And oxygen takes a little while to get to those cells. So it takes on the order of seconds. So I talk fast. I probably listen fast, and I can probably understand things really fast. So a lot of stuff happens in 2 seconds. And so to say that we know what's going on, that the words right now in that network, our best guess is that whole network is doing something similar, but maybe different parts of that network are doing different things. And that's probably the case. We just don't have very good methods to figure that out right at this moment. And so